Hello students. In this class we will discuss the refraction of light, right? In the previous two videos of refraction we have done all the phenomena related to refraction including incident ray, refracted ray, angle of incidence, angle of refraction और उसके बाद हमने एक फिनोमेना डिस्कस किया था टोटल इंटरनल रिफ्लेक्शन का, right? What were the two conditions of total internal reflection? But for total internal reflection, there were two conditions. Number one, the ray must move from dense medium to rare medium, and angle of incidence must be greater than the critical angle, right? At this point of time, you know all the formulas of refraction. We have to discuss this last point in which the syllabus says that describe the use of optical fibers, particularly in telecommunications, stating the advantage of their use in each context, right? Now, what is optic fiber? बच्चों अब आपने देखा होगा you have fiber to home internet at your homes. For example, आपके पास साइबर नेट है, आपके पास स्ट्रॉन्ग फाइबर है, आप कहते हैं कि ग्रेटर बैंडविड्थ मिल रही है, ग्रेटर स्पीड मिल रही है. So the fiber to home is basically optic fiber, right? So what is traveling inside optical fiber? ये optic fiber, that is बच्चों pure light. Communication is taking place at speed of light. ठीक है, उसमें कोई इलेक्ट्रिसिटी ट्रैवल नहीं कर रही. So we need to know what is optic fiber. For that we will have a look at this image, right? Now this shows optical fiber cables. but जो optic fiber cable एक fine hair like fiber होता है but with very complex construction. जरा इसका क्रॉस सेक्शनल एरिया देखिए शाबाश. The innermost glass is called glass core और याद रखिएगा core is a dense medium, right? Core जो है that is dense medium. And then you have a cladding which is comparatively a rare glass. And then you have a protective sheath, protective coating. So what happens inside this optic fiber is the light travels inside the core by the phenomena of total internal reflection. तो लाइट ऐसे बाउंस करती हुए विद इन द फाइबर आगे आगे ट्रैवल करती है एंड दैट बाउंसिंग इज प्योरली टोटल इंटरनल रिफ्लेक्शन. ठीक है. सो बेसिकली ये जो वायर होती है ऑप्टिक फाइबर उसके अंदर ये फाइन फाइबर प्रेजेंट होता है. सो कम्युनिकेशन इज टेकिंग प्लेस इन ऑप्टिकल फाइबर एट द स्पीड ऑफ लाइट. नाउ लेट्स सी द कंस्ट्रक्शन ऑफ ऑप्टिक फाइबर. मैं आपको ऑप्टिक फाइबर ड्रॉ करके दिखाता हूं. जैसा कि हमने ऊपर देखा कि ऑप्टिक फाइबर की दो लेयर्स हैं, वन इज कोर एंड वन इज क्लैडिंग. सो आई विल ट्राई टू ड्रॉ दीज टू लेयर्स. सो लेट्स अज्यूम दैट दिस इज द इनर लेयर एंड दिस इज कोर और यहां पर हम दूसरी लेयर भी ड्रॉ करेंगे. दिस सेकेंड लेयर इज रेफर्ड एज क्लैडिंग. ठीक है, मैं इस डायग्राम को कंप्लीट करता हूं टू फॉर्म दिस ऑप्टिक फाइबर. This inner glass layer is core. This is core of optic fiber. ठीक है, and this is comparatively denser medium. And outside this core, there is another glass layer. ठीक है, and this layer is referred as cladding. Right? So this is cladding which is comparatively less dense. So I can call it rare medium. So what happens is that light travels inside the core by the phenomena of total internal reflection. What were the two conditions of total internal reflection? First condition was light must travel from dense medium to rare medium. तो याद रखेंगे कि इस केस में लाइट ट्रैवल करेगी फ्रॉम कोर विच इज मोर डेंस टूवर्ड्स क्लैडिंग विच इज कंपैरेटिवली less dense medium, right? तो एक condition meet होगी that the rays are traveling from dense medium to rare medium, from core to cladding. And what was the second condition of total internal reflection? That angle of incidence must be greater than critical angle, right? So how the rays travel inside this core? आप यहाँ पे लाइट को जिसके ऊपर आपने कम्युनिकेट करना है इस एंगल पे इंसिडेंट करते हैं such that this is incident ray, this is incident ray, and this line, the line which is making an angle of 90 degree with the surface, with the boundary, this line is referred as normal. So point out where is the angle of incidence. बच्चों this is the angle of incidence. आप इस केस में लाइट को, इंसिडेंट रे को इस एंगल पे इंसिडेंट करती हैं such that this angle of incidence is greater than critical angle, so that आपकी ये वाली कंडीशन मीट हो, that is angle of incidence must be greater than critical angle, right? So angle of incidence is greater than critical angle, and the ray of light is traveling from dense medium, that is core, to the rare medium, which is cladding. So in this case, both the conditions of total internal reflection are met. So ये किस एंगल पे आ रही है रे? इन दिस केस दिस एंगल इज 23 डिग्री, तो ये इसी एंगल पे रिफ्लेक्ट हो जाएगी. इट विल बी रिफ्लेक्टेड एट एन एंगल ऑफ 23 degrees. So here is angle of 23 degrees. Right? So what is happening at this point X is the phenomena of total internal reflection. Right? Total internal reflection. Right? फर्दर ऑन देखिए अब नेक्स्ट पॉइंट पर क्या होगा. जब रे जो है इस पॉइंट पर रीच कर रही है, वंस अगेन यू कैन सी कि यहां से भी रे ने बाउंस होना है. ठीक है. सो आई एम ड्रॉइंग नॉर्मल वंस अगेन एट दिस पॉइंट. Let's call this point of incidence point Y. Now what is happening at this point Y? Right? This is angle of incidence now, and once again this angle of incidence is greater than the critical angle of that material which is core. Right? तो इस केस में light once again bounce back होगी with the same angle, that is 23 degrees. And once again the phenomena of total internal reflection is taking place. Right? तो यहां पर भी reflection हुई. So what is happening at point X and point Y? बच्चों at point X and point Y the phenomena of total internal reflection is taking place. Right? So in this way light inside the core of optic fiber bounce करती हुए, बाउंस मतलब टोटल इंटरनल रिफ्लेक्शन के फिनोमेना के थ्रू आगे और आगे ट्रैवल करती रहती है. सो व्हाट आर द फ्यू एडवांटेजेस ऑफ कम्युनिकेशन ओवर ऑप्टिक फाइबर? बच्चों एक तो आपकी हाई स्पीड पर कम्युनिकेशन हो रही है, एंड दैट इज स्पीड ऑफ लाइट. यू हैव ग्रेटर बैंडविड्थ, आपके सिग्नल की अटेनुएशन कम होती है. What is attenuation? Attenuation means decrease in signal strength. So basically आपको amplifiers को greater distance पर deploy करना पड़ता है because आपको early amplification नहीं चाहिए होती. तो जब आपको less number of amplifiers required होंगे तो आपकी cost of system reduce करेगी. Moreover, because your information is digital information, not analog, उस केस में आप उसको encrypt भी कर सकते हैं. So that will result in high security. जब आपका डाटा एनक्रिप्टेड होगा तो उसको डिसाइफर करना बहुत मुश्किल या इम्पॉसिबल हो जाएगा. दैट्स व्हाई आपके डिजिटल डाटा की हाई सिक्योरिटी होती है. सो दिस इज हाउ यू कम्युनिकेट ओवर द ऑप्टिक फाइबर. राइट? सो दिस वाज ऑल अबाउट रिफ्रैक्शन एंड टोटल इंटरनल रिफ्लेक्शन. सो in this video we will move to some questions of refraction and total internal reflection. So I have selected quite a few questions for you, and these all questions are MCQs. So have a look at this first question. In this question, the statement says that light passes from air into the glass block of refractive index 1.5 as shown. Right? What is the angle of refraction in the glass and what is the critical angle? Right? तो बच्चों सबसे पहले इसको आप देखें कि is it a case of dense to rare या rare to dense? So first medium is air, which is a rare medium, and second medium is glass which is dense medium. So basically rays traveling from rare medium to dense medium. What was the formula of refractive index when the rays were traveling from rare to dense medium? That formula was refractive index n is equal to sine I over sine r. The angle of incidence is angle between the normal and the incident ray, and that angle is 57 degrees, right? So substitute the values. What is the value of refractive index? Refractive index is equal to 1.5. 1.5 is equal to sine of angle of incidence, which is 57 degrees, divided by sine of angle of refraction. So sine of angle of refraction is coming out to be sine 57 divided by 1.5. From here we will sort out the value of angle of refraction. So sine of 57 divided by 1.5 and sine inverse of answer sine 57 divided by 1.5 is 0.559 and sine inverse of this value is 33.99, which is approximately equal to 34 degrees. So the value of angle of refraction is 34 degrees, right? Now you have to sort out the value of critical angle. So what is the formula of refractive index in terms of critical angle? That formula is n is equal to 1 divided by sine of critical angle. The value of refractive index is 1.5. 1.5 is equal to 1 divided by sine of critical angle, right? So 1 divided by 1.5 is 0.667 and sine inverse of this value is 41.8. So the value of critical angle is 41.8, which is approximately equal to 42 degrees, right? So the value of angle of refraction is 34 degrees and the value of critical angle is 42 degrees. आप देखिए what is the right answer? The right answer in this case is option A, right? Have a look at next question. So the next question says that a ray of light is incident on the surface of glass block as shown in the diagram below. The refractive index of glass is 1.5. The light ray changes direction when entering the glass. What is angle X? Right? Acha bacho, once again this is a case in which the ray of light is moving from air to glass. That is, it is moving from rare medium towards dense medium. ये dotted line क्या predict कर रही है इस केस में? Dotted line is showing the initial direction of this ray. अगर ये रे डेविएट ना हो तो ये इस लाइन के अलॉन्ग आएगी, राइट? सो अगर मैं इस ग्रेटर एंगल को देखना चाहूं तो दिस ग्रेटर एंगल इज 45 डिग्रीज बिकॉज दिस एंगल इज 45 डिग्रीज. So in this case, angle of incidence is basically the angle between the incident ray and the normal, and that angle is 45 degrees. Angle of incidence is 45 degrees और ये वाला एंगल भी जो है ये 45 degrees है. Now you have to find out the value of angle of refraction. ठीक है? Angle of refraction देखिए शाबाश. For that you have to apply the formula. देखिए light is traveling from rare medium to dense medium. So you will apply this formula. Refractive index n is equal to sine I divided by sine r. याद रहे कि ये एंगल x जो है ये साइन एंगल ऑफ रिफ्रैक्शन नहीं है बल्कि ये नीचे वाला एंगल ऑफ रिफ्रैक्शन है. सो 1.5 इज इक्वल टू साइन ऑफ एंगल ऑफ इंसिडेंस विच इज 45 डिग्रीज डिवाइडेड बाय साइन ऑफ एंगल ऑफ रिफ्रैक्शन. r इज इक्वल टू, हम इसको सिंप्लीफाई कर लेते हैं, साइन 45 डिवाइडेड बाय 1.5 and then sine inverse of this value. So r is coming out to be 28 degrees. ठीक है? तो ये टोटल एंगल जो है, दिस टोटल एंगल इज 45 डिग्रीज और जो आर है दैट इज 28 डिग्रीज. सो एक्स इज इक्वल टू 45 minus r which is 28 degrees. So x is 45 minus 28, that is 17 degrees, right? So the value of angle x is equal to 17 degrees and the answer is option C, right? Shabash. Have a look at this next question. In the next question it says that the ray of light is in the glass is incident on the surface at an angle of C, where C is critical angle. ठीक है? The angle C is a critical angle. Which diagram shows what happens to the light? बच्चों light जो है वो जब refract होगी it will be refracted at an angle of 90 degrees, because when angle of incidence is equal to critical angle, the angle of refraction, corresponding angle of refraction is always equal to 90 degrees. So, answer is option D. याद रहे, जब आपका एंगल ऑफ रिफ्रैक्शन 90 डिग्री होता है तो उस पॉइंट के ऊपर आपके पास पार्शियल रिफ्लेक्शंस भी होती हैं. सो बेसिकली ये रिफ्लेक्टेड रे आपकी पार्शियल रिफ्लेक्शंस को शो कर रही है. पार्शियल रिफ्लेक्शन. बट याद रहे जैसे ही ये एंगल क्रिटिकल एंगल से थोड़ा सा भी इंक्रीज हो जाएगा, देन योर लाइट विल बी टोटली इंटरनली रिफ्लेक्टेड rather than having partial reflections. So have a look at next question. In the next question, a ray of light in a transparent medium of refractive index 1.8 meter is incident on the surface as shown. The light enters air. Now it is very clear that light is moving from the medium to air. So in this case, it is case of dense to rare, right? So angle of incidence in dense medium is 30 degrees. Okay, because it is an angle trapped between the normal and the incident ray. What is the angle between the refracted ray and the normal? So basically he is asking you for the value of angle of refraction. याद रहे कि जब भी ये रे रिफ्रैक्ट होगी रेयर मीडियम में it always moves away from the normal. तो बेसिकली आपका एंगल ऑफ रिफ्रैक्शन जो है दैट विल बी ग्रेटर देन एंगल ऑफ इंसिडेंस. सो एंगल ऑफ रिफ्रैक्शन की वैल्यू 30 से तो ग्रेटर आने वाली है, बट इसकी वैल्यू फाइंड आउट करने के लिए आप इसके ऊपर शाबाश फॉर्मूला अप्लाई करेंगे. व्हाट इज द फॉर्मूला व्हेन द रे इज मूविंग फ्रॉम डेंस मीडियम टू रेयर मीडियम? द फॉर्मूला इज रिफ्रैक्टिव इंडेक्स n इज इक्वल टू साइन r divided by sin I. Right? Now, what is the value of refractive index? 1.8 is equal to sine R divided by sine 30. So, solve it for the value of R. Cross multiply करेंगे. Sine R is coming out to be 1.8 multiplied by sine 30 and this value is 0.9. Right? R is equal to sine inverse of 0.9. So sine inverse of 0.9 is coming out to be 64.1. ठीक है? What is the angle between refracted ray? This is refracted ray and normal. This is normal. So this angle is angle of refraction. Its value is coming out to be 64.1. So what is the right answer? Right answer is 64. बच्चों ये सारी वैल्यूज को उसने राउंड ऑफ किया हुआ है टू द नियरेस्ट एंगल, तो पॉइंट्स वाली तो कोई ऑप्शन ही नहीं है. वी आर ओनली लेफ्ट विद दिस ऑप्शन. सो द राइट आंसर इज ऑप्शन डी विच इज 64 डिग्रीज. मूविंग ऑन टू द लास्ट क्वेश्चन ऑफ दिस क्लास. याद रहे कि दिस क्वेश्चन इज अ बिट कॉम्प्लेक्स, और याद रहे कि एंगल ऑफ इंसिडेंस और एंगल ऑफ रिफ्रैक्शन, all of those angles are measured with respect to this dotted line, and this dotted line is referred as normal, right? So light is moving from air to the block of glass, so it is a case of rare to dense. ray of light is moving from rare medium to dense medium. Okay? So the question is, light passes from air into a block as shown. Which expression is equal to the refractive index? Right? So you have to identify angle of incident. तो arrows के हिसाब से this ray is incident ray and this ray is refracted ray. ठीक है? So point out angle of incidence. This W is angle of incidence and Y is angle of refraction. So angle of incidence is equal to W and angle of refraction is equal to angle Y. Right? What is the expression of refractive index when the ray of light is moving from rare to dense? In that case, the formula of refractive index is sine of angle of incidence divided by sine of angle of refraction. So the value of sine of angle of incidence is W and angle of refraction is Y. So this would be sine of W divided by sine of angle Y. ठीक है? देखिए शाबाश, which option is the right option? In my opinion, जो आपका आंसर सामने नजर आ रहा है, this is option A. So A is the right answer. Right? So in this video we have studied total internal reflection. We have studied how the light travels inside the optical fiber, and we have done all the questions related to refraction. Right? So stay tuned for the next video. Thank you.